Hi, how are you all doing today? Now we're going to have some fun with numbers. We learn with experience. Before I used to do the arithmetic while filming. What I do now is I prepare ahead of time because it gets tricky while writing and filming and getting it all right. And also I might make a mistake while writing, so I prepare my notes ahead of time. Do you notice a pattern here? 1 equals 1. 1 plus 3 is 4. 1 plus 3 plus 5 is 9. 4 is 2 squared. 9 is 3 squared. 1 plus 3 plus 5 plus 7 is 16, which is 4 squared. We notice the pattern. We start off with 1 and we keep increasing by 2's. It always equals the next number squared. What we have on the left is an arithmetic sequence or series, depending on interpretation of the book. That's where we start off with one number, and what we add on increases by the same amount, like it's 1, 1 plus 2, 1 plus 2 plus 2. That's 1, 1 plus 2, 1 and 2 lots of 2. That's 1 and 3 lots of 2, etc. Another way we can write it is A plus D, A plus 2D, A plus 3D, etc. Now, is there a formula to work out what the total is? Well, if it's just 4 terms, it's not difficult to add it up. What if it's 100 terms or 55 terms? Are we going to add up 55 terms? Well, we've already noticed a sort of pattern if it's going up by 2's. So what I'm going to do is just pretend it's A plus D, A plus 2D, A plus 3D, where A and D could be anything. Let's say it could be 7, 7 plus 4, 7 plus 2 lots of 4, 7 plus 3 lots of 4, etc. So it's any set of numbers in this pattern. So what I do is I'm going to write it like this. We've got A plus D, A plus 2D, A plus etc. Because that's, you see, it's all going up by the same amount. And I'm going to, the last term is n minus 1d if there are n terms. Because look here, if there's 4 terms, that's the second term is 1 lot of d. The third term is 2 lots of d. The fourth term is 3 lots of, in this case, that d is 2. Okay, and I let that equal y. And what I do is I rewrite it underneath just in the opposite order. So A is there, and that final term is here. And while each of these are increasing by d, here from the left to right, they're going down by d. And what happens, so here we've got 2 lines. Now it makes sense if each of these are going up by the same amount and these are all going down the same amount. If I add each term, I should get the same total in each column because the increase and decrease is the same. Now, if I add these 2 terms, I get 2a plus n minus 1d. And I add these terms, 2a plus n minus 1d, and all the terms in between equal the same. So instead of saving, so there's 2a plus n minus 1d, and that's the last term. Anyway, now instead of rewriting it all n times, I can just say n lots of those terms. It's like if I have 8 lots of 7s, I can just say 8 times 7. So it's n lots of those terms. And if 2y equals that, y equals this total divided by 2. And that now is the formula for an arithmetic equation, for adding up all the terms of an arithmetic series. So that's where a is the first term and d is the difference that it goes up, and n is the number of terms. Now, in this particular arithmetic series, a is 1 and d is 2, because each term goes up by 2. Now, if it's 4 terms, I really don't need a formula, because I can just add up these 4. But if it's 75 terms or 93 terms, well, we now have that formula. So now, in this case, I'm going to rewrite the formula underneath over here. As we know, for this particular arithmetic series, a is 1, so I replace that a with 1, and that d is 2. So I replace that d with 2, and there's a 2 underneath. And now I just simplify. So instead of 2 times 1 is just 2, and I multiply that out. That's 2n minus 2. The 2's cancel out. We're left with n times 2n divided by 2. Those 2's cancel out, and that simplifies to n squared. That tells me if I have an arithmetic series where a equals 1 and d, the amount increasing each time is 2, that's plus 2 times 2 plus 3 times 2. That simplifies to n squared. Sure enough, that's what we have here. There are 4 terms equals 4 squared. 3 terms equals 3 squared. 3 squared. So if we have 71 terms, if you've got lots of time, you can add up all the terms. But if you have 71 terms long, 1 plus 3 plus 5 plus 7, going up 71 times, it will simply equal 71 squared. So that's one of the beauties of mathematics. And what we demonstrated here, I just proved on the other paper.